Hello everyone, my name is Mohammed Zahid. I'm from Pakistan. My paper topic is Recent Advances in Neural Network Techniques for Channel Equalization, a comprehensive survey. Let's continue with that. Here are the contents of today's presentation. Problem statement. First, I will discuss what is the problem and why we choose this topic. The second is there is a motivation. What motivated us to do work for that? And area of work. The fourth topic will be the literature survey, which is discussed in detail in this paper. Methodology used, what methodology we used, and equalization tree. It actually gives the detail about the equalization, different techniques used for equalization, and then the comparisons of different techniques, and at the end I will tell about the conclusions and some future research work, and then at the end there will be reference. So let's continue. Here are the problem statement. The problem is the design of artificial neural network based channel equalizer, and there's performance comparisons of different equalization techniques, neural network based techniques. Actually, the research on artificial neural network is the very hot topic nowadays. Since actually it's last 1 decade, it's very hot topic. The research on artificial neural network, especially in the field of digital communication. So more specifically, it's about the designing of artificial neural network based channel equalizer, and different equalizers performance comparisons are discussed in this paper. So the second thing is the motivation. What motivated us? Actually, digital communication systems are designed to transmit high data over communication channels. So during this process, the transmitted data is distorted due to the effects of linear and non-linear distortions. In mobile radio channels, frequent changes dispersion of the and the multi-podcast time dispersion of the digital information known as inter-symbol interference. Actually, this ISI is the main problem in the digital communication. So main objective is to transmit symbols with minimum error. So we have defined our area of work, that is channel equalization. Channel distortion call for channel equalization techniques at the receiver side, which reconstruct the transmitted symbols correctly. So that distortion happens from when the signal transmit from transmitter to receiver. Then in between in the channel there is the distortion occur when it reaches the receiver side, which reconstruct the transmitted symbols. So the purpose of channel equalization to reconstruct that symbols properly. Two kinds of equalizers: preset equalizers and adaptive equalizer. Very famous one. The adaptive channel equalizers play very important role in digital communication systems. Its transfer function is inverse to the transfer function of the associated channel. Here is the adaptive equalizer chain in the chain of transmission system. This block diagram shows the basic the purpose of the equalizer and where it's set in the chain of transmission system. You can look at that. Here is the source, which is actually the transmitter. There is a channel. The noise is added. So here we need actually the training algorithms, the feed with training algorithm here. So here is the error from the output side, and delays, different kind of delays. Actually, because the equalizer give always the delayed output. So this block diagram show the equalizer in the chain of transmission system. Let's move to literature survey, which is briefly discussed in the paper. 1960s, actually research in channel equalization started, that was centered on the basic theory and structure of the zero forcing equalizers. Very famous one, the LMS algorithms, which was given by Withdraw and Hoff, who paved the way for the development of adaptive filters used for equalizations. But that has some limitations. In spite of the best training, it could not provide acceptable performance for highly dispersive channels. From 1970 to 2000, another famous MLS E and its wider beam implementation was famous at that time. So that was the development of first convergence and computational efficient algorithms like RLS algorithms and the Kalman filters. So after the LMS, the RLS algorithms was very famous for channel equalization. And that era from 1970 to 2000, actually from 1980, the research started in 1960, but later from 1980 to 2000, that was the development in the field of artificial neural network. So the MLP based, the very first neural network based equalizer was MLP, the multi-layer perceptron based symbol by symbol equalizer. It was trained using back propagation algorithms, computationally more efficient than the MLSE, but has drawbacks of slow convergence rate. Still it needs improvement. It's discussed in this paper, the complex MLPs, different forms of complex MLPs, and their comparisons. Recent comparison is given in the paper. So the second type is the radial basis function network, RBFN. That was used for approximating functions and recognizing patterns. It uses Gaussian activation function. So later, from 2000 to 2018, the Chebyshev neural network and the functional link ANN. The functional link ANN was a very famous, even at this time, single layer network in which the original input pattern is expanded to a higher dimensional space using nonlinear functions. So both networks, the Chebyshev and the FLANN, provide good performance and comparatively low computational costs. The recent one is the evolutionary algorithms, the genetic algorithms, and the particle swarm optimization (PSO). Later, the FLANN based on PSO training algorithms are designed. The very latest one are the recurrent neural network RNN. RNN can approximate IIR filter, which make them attracted in presence of channels with deep spectral noise. Decision feedback recurrent neural network, another form of RNN actually is the DFRNN. So complex MLP, complex RBF that came in this era, in the recent time. For the recent another kind is the fuzzy neural network equalizer. It is also discussed here in the paper. So pipeline based decision feedback recurrent neural network, it was based on divide and conquer method. Now we move to methodology used. So of course the methodology is used for channel equalization is artificial neural network. So actually nonlinear information processing devices which are built from interconnected elementary processing devices called neurons. It has a natural propensity for storing experimental knowledge and making it available for use. Artificial neural networks can perform complex mapping between its input and output space and are capable of forming complex decision regions with nonlinear decision boundaries. Training or learning actually is determining weights on the connections. So three kinds of famous learnings are supervised, unsupervised training, and reinforcement training. Activation function, it's used to calculate the output response of a neuron. There may be a linear as well as nonlinear activation functions. So so the nonlinear activation functions are used in multi-layer net. Commonly used, these three kind of activation functions are used: sigmoidal function, that's unipolar and bipolar, hyperbolic tangent function, and Gaussian functions. This equalization tree gives the more details about the techniques. Adaptive equalizers, here you can see the supervised training, unsupervised or blind training. Supervised has the MLSE, sequence estimation, symbol estimation. Nonlinear equalizers, linear equalizers. So in the nonlinear equalizer, because we have discussed the nonlinear equalizers in the paper, so classification as a structure on the basis of structure: MLP, FLANN, Chebyshev neural network, RBF, and another new is the Wilcoxon neural networks. Recurrent neural network, that is blind equalizers. Neural network, recurrent neural network blind equalizer. As compared to channel equalization, blind equalization technology bandwidth usage is higher. Its more extensive application space can be applied to a lot of channel equalization. Send training data, the bandwidth is limited, or bandwidth utilization when the rate is high. It is necessary to carry out high-speed data transmission, and blind equalization technology is not required for carrier synchronization, which is beneficial to the project realization of the receiver. Here we compared MLP versus RBF. So with 16 quadrature amplitude modulation, When the channel is really dispersive and noisy, equalizer RBF shows greater strength to additive noise. It is most suitable to this type of channel. As for the equalizer MLP, it has great performance to slightly and moderately noisy channels. This table gives the performance comparison of complex MLP equalizers for QAM equalization problem. So from this equalization, it can be easily shown that the IEC MLP algorithm has less time, so it gives more better performance. It's compared with the training error and the testing errors. For different kind of errors, it has been tested. So here's the comparison of hardware and time complexity: adaptive CMA, non-blind neural network, and blind neural network. So number of additions and number of multiplications is almost the same for non-blind and blind neural network, but with respect to time, the non-blind neural network shows better performance and less hardware complexity. This is the computational complexity of MLP and CFLANN, complex FLANN, which is discussed in detail in the paper. Complex number of operations, we can see here: addition, multiplication, tan hyperbolic, order of Chebyshev polynomial. So the tan hyperbolic, the less number of operations are performed on RDF as CFLANN, so it gives more better performance than the MLP and other complex FLANN. Performance comparison of complex RBF equalizers. Different kind of complex RBF equalizers: complex ELM, fully complex, MC, FCRBF, FCRNN. So it's compared here with respect to that, and you can see the time for training is very less for complex ELM. So complex ELM, extreme learning machines, they are very famous and it gives very good performance. So now the question arises that why neural networks used for channel equalization? Actually, they have adaptive learning, the generalization ability, massive parallelism, and high degree of precision, and fault tolerance. The main thing is the fault tolerance, real-time operation. It gives the real-time operations. So in the conclusion and some future research work, the various recent neural network architectures and learning methods are discussed for the problem of channel equalizations. MLP is very simple to implement, but usually it requires a long training time. FLANN structures have computation complexity problem. RBF based NNN and RNN equalizers are an attractive alternative. So recently, genetic algorithm and particle swarm optimization and Wilcoxon learning has been used to train ANN. In future, SVM can be used to equalize the same kind of nonlinear recursive channel. In summary, paper has provided a detailed review on a recent NNN-based channel equalization. These are the references that are followed in the paper. Thank you so much.